Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, I'll be tackling the third question from the preliminary exam which was written in the year of 2023 in the Torah Academy. Please do expect a total number of 12 videos since the question paper had 12 questions in total. And that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay. We are told that the fifth term of a geometric sequence is 14 and the ninth term of a geometric sequence is 224. There are two geometric sequences that satisfy these conditions. Determine the first three terms of the sequence with a positive constant ratio. Okay, since guys this sequence was described to us, we are not given the sequence itself, so that means we must use the general term or the nth term to determine the values of a and r so that you can find the terms of the sequence. Are you together? I know that Tn is equal to ar to the n minus 1. I was told about the fifth term, so therefore T5 will simply be equal to ar to the power 5 minus 1, which is just equal to ar to the power 4. So T5 is just ar to the power 4, and then T9 is ar to the power 9 minus 1, and hence T9 is just ar to the power 8. The ninth term is equal to a to the power 8, right? So we can simply say, since we are told that T5 is equal to 14, we can therefore conclude that ar to the power 4 is equal to 14. And this is the first equation. And then on the other hand, we're told that T9 is equal to 224. That means ar to the power 8 is 224. This is my second equation. I can simply say equation 2 divided by equation 1. I'll end up having, from equation 2, I have ar to the power 8. On equation 1, I just have ar to the power 4. From equation 2, I have 224. On the other side, I have 14. So whenever I divide my left-hand side, the a's will cancel one another, and then r to the power 8 all over r to the power 4, I will end up having r to the power 4. And then 224 divided by 14, this will simply give me an answer of 16. So I can simply find the fourth root over there, and then r, since guys my root is an even number, that means the right hand side should say plus or minus. But we were told over there guys to find a constant ratio with the positive, find the first three terms with the positive ratio, and hence our r is just equal to positive 2. Then all you have to do guys is to go and find the value of a. How can you find a? You can simply either use one of these equations guys. Let's go to equation 2. We'll simply say ar, which is 2 to the power 8, is equal to 224. And therefore a is just equal to 224 divided by 2 to the power 8. What do we get? 224 divided by 2 to the power 8. You'll simply get an answer of 7 over 8. And hence the first three terms will be 7 over 8. And then the next term, remember that our constant ratio is 2, right? So for us to find the next term, we must just multiply by the constant ratio. Our next term will simply be 7 over 4. And then the third term will simply be 7 over 2. These are the first three terms, guys, of our sequence that has a positive constant ratio. And then now they want us to determine the 10th term of the sequence. I know that Tn is equal to ar to the power n minus 1. So T10 will simply be equal to a, that's 7 over 8, r, that's a positive 2, and then I'll simply have 10 minus 1 as my exponent. This will give me an answer of 7 over 8 multiplied by 2 to the power of 10 minus 1. So the answer is just 448. So the 10th term of my sequence will simply be 448. And then now, guys, we are told that the nth term of a number pattern is as follows. Tn is equal to this if n is an even number. And then Tn is equal to that if n is an odd number. So over here, guys, we have a combination of sequences in this one number pattern, such that the positions that are held by odd numbers, such as T1, T2, T3, not T2, man. Positions held by odd numbers. If I have a sequence like this, yeah. Let me just try and maybe write the 5, 6, 7, 8. Okay, we were told that, guys, if n is an odd number, that means the general term is equal to this, né? And this is a general term for a quadratic number pattern, such that T1 will be a quadratic number pattern, T3, T5, T6, etc. Are you together? And then the other nth term is for the terms that occupy the even positions, T2, T4, T6, and T8. That was supposed to be T7 over there, né? The red ones, guys, they represent n if n is an odd number. Are you together? These are the terms whereby n is an odd number. Obviously 1, 3, 5, 7, 9, 11, etc. Those are odd numbers. And then 2, 4, 6, 8, 10, 12, etc. Those are even numbers. So if I want to find, for example, the first question, they want me to find the sum of the 6th term and the 7th term. Are you together? 6 is an even number, so I will use this general formula to determine the 6th term, and I will use the other general formula to determine the 7th term, because 7 is an odd number. So over here, guys, I can simply say T6 is basically equal to negative 5 multiplied by 6 minus 4. That's negative 30 minus 4, it's negative 34. And then T7 is equal to negative 7 squared plus 6. That's negative 49 plus 6, which will give me negative 43. And hence T6 plus T7 will simply be equal to negative 34 plus a negative 43. And that will give me negative 77. Okay, now I'm supposed to show that this number over here or this term over there cannot be the value of an even number. I can simply equate this term to this guy over there, and if I get an odd number, that means I've proven that this cannot be a value of an even number. So how can I do that? I'll simply say Tn which is equal to negative 5n minus 4. I want to check whether negative 219 is even or odd. So if I get an even number, that means this term over here belongs on the even position. But if I get an odd number, I would have proven that this term cannot be an even term. So if I take the negative 4 to the other side, I would end up having negative 215 being equal to negative 5n. Divide both sides by negative 5n. You'll simply get n to be equal to 43. Is 43 an even number? No. 43 is an odd number. So that's why this term cannot be generated using this particular general formula over there. This term belongs on the quadratic number pattern. Okay, so now they want us to determine n if Tn is equal to that. Né? So Tn is equal to negative n squared plus 6. I already know that this belongs to the quadratic number pattern. That's why I'm using the nth term for quadratic number patterns. This is negative 219 minus n squared plus 6. If I take the 6 to the other side, I'll end up having negative 225 is equal to negative n squared. Divide both sides by negative 1, and then n squared will just be equal to 225. Then square root on both sides, plus or minus 15. Therefore, n is 15. Eh? So the 15th term is basically negative 219. The 15th term. Okay. Now they want us to determine or rather we are told that the first 4 terms of a quadratic sequence are shown below. Né? Remember that, guys, the quadratic sequence has 2 differences, right? It has the first difference and the common and the second difference is common. Né? The first difference will be arithmetic, the second difference will be common. So if these are my terms of my quadratic number pattern, let's find the first difference. How can I find the first difference? I can simply say t2 minus t1, I will end up having m squared minus 6, and then t3 minus t2, I will end up having 6m minus m squared, and then t3 minus t2, you'll end up having 5m minus 2. Are you together? And then you can find the common ratio over there, guys. We can simplify the common ratio. This minus that. Okay, I have 6m minus m squared minus m squared minus 6. So this will just be 6m minus m squared minus another m squared plus 6. Why do I say plus 6? This was supposed to be 4, guys, né? Because if I subtract these and these, I'll be left with m squared plus 4. M squared plus 4. Excuse me about that. And then I'll simply have 6m minus 2m squared plus 4. So I'll have 6m minus 2m squared plus 4. And then if I take this and subtract that, I'll simply have 5m minus 2 minus 6m minus m squared. That's 5m minus 2 minus 6m plus m squared. So this will end up giving me m squared minus m minus 2. I will have m squared minus m minus 2. So these two, they belong in the second difference, and I know that my second difference is common. I can therefore conclude that this simply means m squared minus m minus 2 is equal to 6m minus 2m plus 4. Then I must bring everything into standard form. If I bring everything into standard form, guys, if I take this to the other side, I'll have m squared plus 2m squared. That will be 3m squared. Né? And then negative m minus 6m, that is just negative 7m. Negative 2 minus 4 will just give me a negative 6. So all I have to do now is to simply factorize. I will have 3m, m, 3 and 2, and then I'll have negative and positive over there, and hence m is equal to negative 2 over 3, or m can be equal to a positive 3. That's how, guys, we're supposed to tackle that question over there. And then the last question, we are given sigma notation. Now together, over here we have unknowns, and we just want to find the value of p, right? So let's deal with this one first, because this is an arithmetic sequence. How do I know it's an arithmetic sequence? By just finding the first 3 terms, right? If I substitute t as 1, I'll end up having 24 minus 3. My first term will be 21. My second term will be 18. Third term will be 15. And then the last term, I'll just substitute 12 over there. I'll have 24 minus 3 times 12 for my last term, and the answer is just negative 12. So I know the value of A is 21. The common difference will be equal to negative 3. N is always top minus bottom plus 1. So that's 12 minus 1 plus 1. The answer will be 12. And then my last term is just equal to negative 12. So therefore, I can simply calculate the sum over there. The sum of n is equal to n over 2. Since I have the last term, guys, I can simply say A plus L. So n is 12, and then the first term is 21. The last term is just negative 12. So whenever I punch my precious calculator, I'll end up having 21 minus 12 inside the bracket. I'll end up having 54. So now I know that, guys, this sigma over here, 27 p to the power k, this is equal to 54. That sigma over there is equal to 54, guys. Are we together? So sum to infinity is basically equal to 54. So all I have to do is to find the values of A and R. How can I find the value of A? By just substituting different values of K starting from 1. So the first term will simply be 27p. The second term will be 27p squared. Third term will be 27p cubed, etc. until infinity, such that the value of A is just equal to 27p, R is just equal to p, and my sum to infinity is equal to 54. So I can therefore use sum to infinity to find the value of p. Sum to infinity is equal to A 1 minus R. That's just 54 being equal to 27p all over 1 minus R. If I cross multiply, I'll end up having 54 multiplied by 1 minus R is equal to 27p. I don't know why I didn't substitute the value of R, because I already know it. The value of R, guys, is p, ne? I already know the value of R. Okay, so now I'm supposed to remove the brackets. I'll end up having 54 minus 54p is equal to 27p. Then 54 will be equal to 27p plus 54p. This is 81p. Then if we divide both sides by 81, therefore the value of p will simply be 2 over 3. The value of p will simply be 2 over 3. That's how, guys, we're supposed to tackle the third question over there. So please, guys, do stay tuned and wait for more videos. Thank you.